Hello everyone. Today I'm going to look at the Pythagorean Theorem, arguably one of the most well-known theorems in mathematics. Most people remember it long after leaving school, even if they don't fully understand it or where it came from. So today I'm going to kind of look at one of the many proofs for why this is true. So the Pythagorean Theorem says a squared plus b squared equal to c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So I need to start with a right triangle. And you can change the shape and the size as long as you have a right angle. And that's all that really matters. So I'm going to start with this thing piece by piece. Let's start with a squared. Well, that is a square with side length a. So if I think of a as this leg on the left, and I think of a square where that's one of its sides, I would have a square of size a squared. And I can do something similar with the other two sides to get squares of size b squared and c squared. So now what I'm claiming with the Pythagorean theorem is that the area of the blue square and the red square added together is the same as the area of that green square. So let's look at how we might do this. And let's do that by starting to look at just the a squared and the b squared. So I'm going to move them over to the side to look at them separately. And I'm going to fill in this bigger square here. So now my side lengths are a plus b. So total, I have a square with side lengths a plus b. So now let's see how we can rearrange them. Essentially what I have here is a square that consists of a squared and b squared plus these 4 extra triangles. So I'm going to start by looking at the 2 top triangles, and I'll just slide them over to the side to deal with them. And then what I want to do is essentially hinge the bottom one out, just like this. So I'm starting to form a bigger square here. I can repeat this process for the other 2 triangles down at the bottom, and I can see this much bigger square. So I can also see that along the top is a b and an a, and along the side is an a and a b. So the area of the square on the right is the same as the area of the square on the left. But what about this center white part? Since each one of these triangles have legs a and b and right angles, that means this third side of these triangles is just a c, which means that that blank area is just c squared. So on the left, I have a squared plus b squared plus 4 extra triangles. And on the right, I have c squared plus 4 extra triangles. And those are the same because those squares are the same size. So if I remove all of the extra triangles, I would have an a squared plus b squared has to be equal to that c squared on the right. Everyone, I hope you enjoyed that video. This is part of a new series that I'm doing called Why Math that looks at why some of these commonly known mathematical facts are actually true. So if you have a particular topic you'd like me to explore, please let me know in the comments. In addition, please like the video, subscribe, share with your friends, and please consider supporting me on Patreon. All of my links are in the description.